Hello guys, my name is Madhav Ansala and today I'm going to teach you about projectile motion. So let's go ahead and know what basics we should know about. First of all, we should know about the three basic equations of motion in one dimension, that is uh, V equals to U plus AT, uh, S equals to UT plus half AT square. This is A. We should also know about V square minus U square equals to 2VS. We should know about basic vector mathematics, that is, for example, say there's a velocity u which makes an angle theta with the horizontal, so it can be divided among two components, u cos theta and u sin theta. So now let's get to understand what we need to study. We need to study the path that an object at say origin with velocity u thrown at an angle theta from the horizontal axis will follow to get down here. Say this is the path it follows. So we need to know the characteristics. What characteristics we need to find? We need to know the time of flight of this projectile. We also need to know the maximum range it will achieve and the maximum height it has reached. So to get to know all this, we first need to understand how we will do this. So the first thing we'll do is we'll divide the velocity among two components, u cos theta and u sin theta. Now uh, we know that along the x-axis there are no forces whatsoever being applied. So if we know the time of flight, we can simply calculate the horizontal range as u into t, because acceleration is 0. That's why this will be a simple motion and the distance traveled can be simply found out by speed into time because it's constant. Although along the vertical axis there is an acceleration g being applied on the downward side. So this will be the axis we'll use to calculate the time of flight, because the object will go up and then it will come down. The same amount of time will be given to the horizontal components will get to travel along the x-axis before it finally settles down. Okay, so let's go ahead and first calculate time of flight. So to calculate time of flight, uh, we know that v equals to u plus at. So now what should be the values of v, u and at, whatever? We need to find the time of flight. That is, this is the variable we need to find out. We need to know the value of all other three components. V is the final velocity. Let's take the half cycle, that is the cycle when the object goes up and stops here. Now the point when it stops in the air, the word stop means that its velocity has become 0. That means v is 0 at this point. Initial velocity along x-axis, as we have found out here, will be u sin theta plus acceleration due to gravity is g among the opposite direction. Since the direction is opposite, we'll use minus g, and t is what we need to find. So we will take this to this side. G into t equals to u sin theta, t equals to u sin theta by g. Now when there are no losses, just a second, when there are no losses, we can say that the same time of flight will be there when the object will come down. So say this is time up, so time down will be equals to will also be equals to u sin theta by g. So total time of flight is equals to 2u sin theta by g, which is summation of T up and T down. Okay, so now let's understand how we will find the horizontal and vertical maximum height is, that is horizontal, maximum height is, that is vertical height, and the maximum horizontal range. To find the maximum vertical height, we know that the time of flight before it reaches the maximum point is T up, which is equal to u sine theta by g. So now T up is known to us. We can simply find out the distance traveled using v square minus u square equals to 2as. Final velocity, as we all know, is 0 minus u square is u sine theta here. This whole square equals to minus minus g. I have written a here into 2 into distance traveled is what we need to find. Now minus u square sine square theta equals to minus 2gs. This minus and this minus will get cancelled. We will move 2g down here. Therefore, distance travelled as is equals to u square sine square theta by 2g. Okay. Now, this is the maximum height reached by the the projectile. To find the horizontal range, we already know that total time of flight, that is time up by time plus time down, which will the total time the horizontal component will remain unchanged before the final settle down time arrives for it, like it reaches the sand again from where it started, will be 2u sine theta by g. Now, because of this, we can write that we know that the time period will be 2u sine theta by g for the horizontal motion, as we have already found out, 2u sine theta by g. So, the velocity is constant, so s equals to ut can be used, right? Because half at square will be 0 because a equals to 0 along the x-axis. So s is equals to u, that is u cos theta here into 2u sine theta by g from here. Now s equals to u square into 2 sine theta cos theta by g, which can be written as s equals to u square sine 2 theta by g. This is the horizontal range. Now let's get to know some points. The maximum range is achieved when the maximum horizontal range is achieved when theta is equals to 45 degrees. When theta is 45 degrees, sine 2 theta becomes 1, because of which u square by g is the highest value. Because let's understand some point. To maximize this, u square is a constant, g is a constant. The only thing we can maximize is sine 2 theta. What is the maximum value of sine 2 theta? The maximum value of sine 2 theta is 1. So, if any time question comes, what's the angle when it's maximum? It will be 2 theta equals to sine inverse of 1. Which will give 2 theta equals to 90 degree. We are assuming that all angles are within plus 90 to 0 range. So theta will come out to be 90 by 2, which is equals to 45 degree. Also, the maximum vertical height, the condition for maximum vertical height, we know the formula u square sine square theta by g. In this case, sine square theta is the parameter we need to maximize. When will be sine square theta maximized? Let's see. Sine square theta is sine theta's square. Its maximum is 1 square. When is sine theta 1? When theta equals to 90 degree. So to maximize this, to have the maximum height for a projectile motion, we need theta equals to 90 degrees. In which case, basically instead of projectile motion, we'll be doing motion in one dimension along the vertical axis. Okay. Thank you guys. These are the main topics about projectile motion.